So we've seen how to solve quadratic equations by factoring, and we've seen how to solve them using the square root property. But sometimes you have a trinomial, you just can't factor it. It just won't factor its prime. And it's not very easy to get it to where you have a perfect square. Like if I had this, I'd have to find what number I'd have to add to that and make that perfect squared, and it gets kind of complicated. So what they do is they do a technique called completing the square. They find the number you'd have to add to that to make that into a perfect square. And then you go ahead and you work it out and solve it. And when you do that for a general equation of ax squared plus bx plus c equals 0, you get what's called the quadratic formula. And so this allows me to numerically just identify what a, b, and c are, and then I just plug it into the formula and then calculate the answer. So let's see how this is done here. So here I've got x squared minus 3x minus 3 equals 0. So just like when we were factoring, the critical thing is you have to have 0 on one side before you do anything. A is always the coefficient of the square term, B is always the coefficient of the x term, and C is always the constant term. So here in this example, my A here would be 1. My B would be negative 3. And my C would also be a negative 3. And now I just plug into the formula. So wherever I see an A, I put it here and here. A is 1. So I'm going to put that here and here. Then wherever I see B, I'm going to put in this pink negative 3. So negative 3 here and negative 3 here. And then I'm going to put this blue 3 for C here. And now I just need to work on simplifying this. So when we're doing this, let's first deal with this. Double negative, that's a positive. On the bottom, that's a 2. And let me cheat a little bit here and use a calculator. It's kind of early in the morning when I'm recording this, and so I'm going to let the calculator do the work. So I'm just going to enter this negative 3 quantity squared minus 4 parentheses 1 parentheses negative 3. And that gives us 21. So I guess I didn't have to make that quite so long. And the square root of 21, you're not going to be able to break that down. You can just check it real quickly. If you have a TI-30XS, it doesn't break down. So this would be our solution. And you'll see this written two ways. You might see it written this way. The other way, they might actually go through and divide through by 2 and separate this out. So you might see it written as 3 over 2 minus the square root of 21 over 2, and 3 over 2 plus square root of 21 over 2. So really kind of either form is acceptable. Depending on the problem, they want one form or the other. Now, as I mentioned before in the last video, you make sure you know how to enter these to get your decimal approximation. So some of you have commented that, well, I don't have a TI-30XS, so it's not going to allow me to enter this like this. and get my decimal approximation. If that's the case, keep in mind this is the numerator divided by the denominator. So if you don't have your TI-30 XS, or if your calculator is not allowed you to do this, you can take that numerator, put that in parentheses, oops, my bad, delete that. Make sure you get out from underneath that radical, and then you can then put that in parentheses and then divide by 2. And then get your approximation. So that's how you would do it if you don't have a TI-30 XS. Since I do, I'm going to take this one and I'm going to get the other one. I'm going to change that to a plus. So those would be our two approximations if we need to get the approximation. So at this point, I'm assuming you're comfortable with practicing getting that approximation on your calculator. If you need some additional help, you'll feel free to get with me during my office hours or get with a tutor in Math World. They can kind of help you out if you're having trouble getting the approximations on your calculator. So moving on. Let's try this example. Now, key thing here is remember, before you start plugging the quadratic formula, you have to have 0 on one side. So the first step here would be to subtract 3 from both sides. That would give us x squared plus x minus 3 equals 0. So my a here is 1. My b here is also 1. And my c is negative 3. So again, going to my quadratic formula, wherever I see an a, I'm going to plug it in here and here. Wherever I see a b, plug here and here. And I'm going to plug in c there. So my a goes here. My b's go here. And my c goes here. All right, simplifying. I get negative 1 plus or minus. This whole thing's over 2. And let's go ahead and, again, I'm going to make the calculator do the work here. So that's 13. And we can't simplify the square root of 13, so we're done. We got our two answers. Again, I can write this as a negative 1 minus square root of 13. Oops, my bad. Write that better. Minus square root of 13 over 2, and negative 1 plus square root of 13 over 2. The alternate form, again, is where they separate it out. So you might also see it written this way. They're the same thing. Getting sloppy here, sorry. So again, either answer would work. Now, the thing I want you to keep in mind is that this quadratic equation is more generalized. It will work for all situations. If we go through and we factor, solve an equation with a factor, it only works if the equation is not prime. if the factorization is not prime. This will work wherever the thing factors or not. So let's take an example that we had done before. So I'm going to call this, let's see, I don't want to mess up my numbering. We'll call this example 3. I'm just going to take a problem we had done back in a couple videos ago when we were factoring. We had a problem where we had a factor 12x squared minus 17x minus 5 equals 0. So this was back on page 46. We'd gone through, factored out, and we got our solutions. So here's an alternative way I could go and use the quadratic formula. Let's see what happens when we use the quadratic formula. So here I'm going to identify my A. My A is 12. I'm going to identify my B, that is negative 17. And I'm going to identify my C, that's negative 5. And now I'm going to plug it into the quadratic formula. So wherever I see an A, I put a 12 in. Wherever I see a B, I'm going to put in a negative 17. And wherever I see a C, I'm going to plug in a negative 5. And now we're going to simplify like we did before. The opposite of negative, that's a positive, so that's a 17 plus or minus. To the bottom, 2 times 12 is 24. And then again, I'm going to make the calculator do the work on the inside here. So let me grab my calculator. And we've got a negative 17 squared minus 4 parentheses 12 parentheses negative 5. That's 529. Now, let's see if we can simplify the square root of 529. Well, that's 23. So all of a sudden, this is now 17 plus or minus 23 over 24. So let's separate that out. So we'll do minus 23 over 24 or 17 plus 23 over 24. So that's a negative 6 over 24. That is a negative 1/4. This is 17. This is 40 over 24. And excuse me, reducing that, divide by 8, that's 5/3. Now, if you go back to page 46, notice you have the same answers. same thing. So the quadratic formula is a more powerful tool because it works for all the quadratic equations, even if they have irrational solutions or even if they have imaginary and complex solutions. It will work.